everybody, my name is Professor Sabrina Isaac Berry from Berry Science Lab, and today we're going to be looking at Calculus Lecture 7. Graph that agree at all but one point. So let's say we have graph f of x, which is, we'll say, is this monstrosity. And then let's say we have graph g of x, which is this small minus x squared. Now, when you graph it, these may look the same, right? So, even when you graph them, these might look the same. So, let's say this is 2, and let's graph it. And this, we'll say, is, you know what, I am not saying that mouthful. This is f of x. This is f of x. And let's say we have g of x. The same thing, it would look like the same thing for g of x, except we can go in and fill the hole over here. I'm just going to use thicker stuff because it satisfies my needs better. And now, you probably already spotted the difference between these. This has an open hole and this has a closed hole. And you may also notice that these are exactly at the x-coordinates to erase these functions for a second because we already know what they are. 3, 2, 1. Okay, so now it's all clear. So this is how it looks now, much cleaner. And let's, if it's at the x-coordinate of 2, there's an open circle. Let's explore why that could be by plugging 2 into this equation. Well, 2 raised to the 4th power would be 16 minus 4 times x squared. Since x is now 2, 2 squared is 16. And 2 squared is 4. And 4 times 4 is 16. 16 minus 16. But it gets even worse. Because you have 4 minus x is now 2, so x squared. 16 minus 16 over 4 minus 4. 0 over 0. Pretty alarming. So that's why it's undefined at 2. But, well, what about negative 2? Well, negative 2, negative x squared actually has a defined point at x-coordinate of 2. Because if you plug in 2 here, you'll get negative x squared. X is now 4, no, x is now 2, and since we're squaring it, there is an even exponent, so and that's why we're doing this, which I guess we can say we get negative 4. So, this minus x squared is negative 4, an actual physical value. Then why did we get 0 over 0 for one and negative 4 for the other when they look so similar? You might even say, Professor Sabrina, you just copied the same graph twice to get the different graph. How do they have the different answers, different undefined answers and defined answers? Well, this is the example of things that don't agree on just one point. One of them is here. One of them is undefined and one of them is defined. So you can really see the dilemma. But the thing is, let's try and simplify whatever that piece of junk was. x4 minus 4x squared over 4 minus x squared. Now it's pretty obvious that you can factor x squared out of the top and leave it there. So let's do exactly that and factor it out. Get x squared minus 4 over 4 minus x squared times x squared. Now we can really see the real culprit here. But let's go even deeper. Because x squared minus 4, you see, is a difference of squares. And let's just make everything look much better by swapping around the orders of minus x squared and 4. And the thing is, here, minus x squared plus 4 is just what's on top times a negative. So minus x squared minus 4, you can see. But we can go even deeper. Let's factor out the difference of squares here. We can say x minus 2 and x plus 2 is our difference of squares over here. And on the bottom, we can say the same thing. But let's say that we get x plus 2 times negative x minus 2. We've got to conserve this negative somewhere, I mean. So we can cancel out these just to make it simpler. And now you've got x minus 2 over negative x plus 2. Now here's the thing. You have x minus 2 over 2 minus x. How do you do that? Well, you simplify even further. X minus 2 over negative x plus 2. Now, negative x plus 2, of course, can be written as negative x minus 2. Oh, and we also forgot to take this guy and then the cradle. So let's just add that at the end, that x squared that we've been missing. So times x squared. Now you can see this just simplifies to 1 over negative 1. 1 over negative 1 times x squared. And 1 over negative 1 is just negative 1. So you get negative 1 times x squared, which is negative x squared. And that gives you the different results, but with the same kind of function, the same kind of graph. Which is very weird. But that's just how it works. Thank you everybody for watching, and bye. This video was sponsored by Brilliant. Sorry guys. Bye.